Everything that we see before us is made up of small atoms. Be it humans, buildings, asteroids, planets, stars, or entire galaxies, everything is made up of atoms. Atoms combine together to form different kind of elements, which eventually proceeds to the creation of everything. Or should I say, everything that we see. Universe isn't just made up of these atoms. In fact, visible matter only accounts for 5% of the total universe. Rest is made up of dark matter and dark energy. Comprising of 25% of the universe, dark matter is still an unknown mystery. Before getting on the discovery of dark matter, let's see how our galaxies should behave. According to the laws of physics, star systems, galaxies, and clusters of galaxies should behave in a specific manner. Kepler's third law of planetary motion suggests that, for a star system, a planet orbiting the star farther away should have less orbital speed as compared to less distant planet. For our star system, Neptune should be orbiting Sun at a slower speed as compared to Mercury. And it is exactly how it is. Neptune has an orbital speed of 5.43 kilometers per second, while Mercury has orbital speed of 47.87 kilometers per second. Newton's law of motion indicates that the center of a galaxy should have enough mass to keep the stars in its orbit. Meanwhile, stars should have velocity and distance proportional to the center of galaxy to keep in orbit. If a star has low velocity, it will fall into the center of the galaxy. Similarly, a star having more velocity than its proportion will exit its orbit and wander off into space. Fritz Zwicky in 1933 was the first scientist to notice that mass of all the stars in Coma cluster of galaxies was merely 1% of the mass required to keep the galaxies within the cluster's gravitational pull. He immediately deduced that there's something there that is keeping them intact. Since he couldn't make a physical observation, he called it dark matter. This mysterious dark matter was not detected before because of its characteristics. It does not interact with regular matter physically, meaning it could just pass through physical matter without any interaction. The only interaction it has with regular matter is through its gravitational force. If large sum of this dark matter was available somewhere, it could be detected through its gravitational implications. During observation of the universe, it was noticed that the light bent near some regions of space. This further proved the existence of this dark matter. To this day, we don't know enough about dark matter or what it is. We just know that there's something in abundance that has gravitational pull but no physical shape. But that's just 30% of the total universe. What about the rest of the universe? What is it made up of then? The answer was given by two teams of astronomers in 1998. They were observing a distant supernovas called Type Ia supernovae. What they were doing is, they were observing two different supernovas on different distances. Both of these supernovas were known to have consistent brightness. Brightness is very important in this regard, because brightness would tell the astronomers about their distance from us and each other. If it was getting brighter, then it means it's getting closer. If it was getting fainter, then it means it's getting farther. The astronomers noticed that the farther supernova was getting fainter as compared to the closer supernova. They deduced that the other supernova was getting farther away from us at a faster pace. This could only mean one thing. The most believed theory of decelerating universe was not true. It was believed that the acceleration of the universe was slowly decreasing, but this latest discovery changed everything. It proved the opposite. A fainter supernova proves increased acceleration of the universe. Clusters of galaxies are getting farther away from each other instead of coming closer. Distance between astronomical objects is increasing at a faster pace. Scientists began to wonder, how could this be? All this matter in the universe and its gravitational pull should decrease the acceleration of the universe. How can it be the other way around? They could only think of one answer. There must be some kind of force that's opposing the gravity, and that it must be stronger than the gravity itself. They called it dark energy. Like dark matter, dark energy is a mysterious phenomenon too. We don't know enough about it yet. This observation was later further proved by observing galaxy clusters and distant objects. If universe was decelerating, then dynamics of the universe would have been completely different. In current scenario, we are continuously getting farther and farther from other celestial bodies. More and more things are getting beyond our horizon. Many of the celestial objects we see today can never be reached even at the speed of light, and their number is continuously increasing. But who knows what the future might bring? That's it for today. Let us know if you want us to make a video on a topic of your choice. Until then, keep looking up.